For question 18, given a polynomial and question A show that x plus 2 is a factor, hence factorize this polynomial completely. From x plus 2, we can get x equals to negative 2. When you want to show that this x plus 2 is a factor, we will substitute the value of negative 2 into the polynomial, and at here, we cannot write equals to 0. We must calculate until we get 0. So that is the method of showing. So for this part, we are going to write p in the bracket of negative 2. Here we will substitute negative 2. So in order to show it is a 0, we must calculate step by step. So when we can do the calculation equals to 0, now we can say this x plus 2 in bracket is a factor of our polynomial px. Then we are going to factorize this polynomial completely. Since this polynomial is a cubic polynomial and one of the factors we already proved it, in order to find the two factors, we will do our long division. Remember here, you are not allowed to use calculator to get to the answer. Now we are doing our long division. X squared times x will get x cubed. Then we expand for 2, become 2x squared. Then we minus here and bring down this 5x plus 2. Then again we will times 2 and x to the x in order to get 2x squared plus 4x. Finally 1 times x to get x, 1 times 2 to get 2. So finally our polynomial is equals to x plus 2 and the quotient will be x squared plus 2x plus 1. So factorize it completely. For quadratic, we can straight away factorize. These are our factors. Now we're going to express 5x plus 7 over our polynomial in partial fraction. First step, check this fraction, is it proper or not. Therefore, we will substitute 5x plus 7 over the polynomial here will be x plus 2, x plus 1, x plus 1. So we will substitute the factor form of our polynomial. The first step of partial fraction, we will check is it this fraction is proper or improper. Yes, this is a linear. For the denominator, it is a cubic, so this is a proper. Then second step, we will check is it the denominator here factorized completely. Yes, already factorized completely. Then third step, we are going to split our factor. According to the case here, we have a linear factor and a repeating factor. So when you want to split our factor here, linear will be maintained as x plus 2. For the repeating factor, we were going to write x plus 1 for the first time and repeating x plus 1 for the second time. So it will become x plus 1 squared. So this is our third step where we identify our types of our factor. Then step number 4, we are going to determine our general term for numerator, where linear we will put a constant to maintain it is a proper fraction. So when this one is linear factor, so here I will put another constant as b. So for this is a factor that repeating. So this is not a quadratic factor. Quadratic factor means the factor cannot be factorized anymore. So you will see inside here, this is a linear factor, x plus 1. Therefore, for numerator, we will select a constant c. Then we continue for step number 5. We will going to equal the denominator so that we can get an equation. So for 5x plus 7, it will equals to a. So how we equal the denominator? We will multiply the factor where the partial fractions here, the denominator itself, it don't have. So this partial fraction, it have x plus 2 as a factor. So I will multiply with x plus 1 and another x plus 1. For b, so for this b, its denominator, it will have a factor of x plus 1. So I will multiply x plus 1. For c, the denominator here already have 2x plus 1. So I will multiply this c with a factor of x plus 2. So now we're getting our equation. For step 6, we are going to find what is our value of a, b, c. So the method I choose here, I will using let. So let the value of x as our zeros, means let x as our roots of this factor. For example, we can let x equals to negative 2. We can let x equals to negative 1. And we can let one more x, any numbers. So once we have 3 unknown here, we need to let it 3 times with different value of x. Since negative 2 is a root, and then negative 1 is also a root, we have no more roots that we can choose. So we can let any value. So for easier, I will recommend we use the x equals to 0. Now we are going to find what is our value of a, b, c. We will substitute x equals to negative 2 into the equation here. So when x equals to negative 2, here will equals to negative 10 plus 7. So here will become a times negative 2 plus 1, negative 2 plus 1. So for here, negative 2, it will become 0. So whole part, it will become 0. Same as here, negative 2 plus 2 is 0. So leaving our answer is negative 3 equals to a. Therefore, a is negative 3. Then we continue for second value, x equals to negative 1. When we substitute x equals to negative 1, the left hand side here will become negative 5 plus 7, which is 2. Now we substitute negative 1 into the part A here, it will become 0. And then into the part B here also 0, leaving, I substitute negative 1 into the part C here, become negative 1 plus 2, which is equals to C equals to 2. For x equals to 0, we substitute here, we become 7. And then since we get our a ready, so we will use the value of a, which is negative 3. Then 0 substitute inside here will be 1 times 1. It will equals back 1 plus b. Substitute 0 into 2 and 0 into x plus 1. Here we're getting 2 times 1, which is 2. Then plus, for c, we found the value which is 2. Then where x is 0, we substitute, we get 2. Finally, we get 2b equals to 6. So b will equals to 3. Then last step, step number 7, we will substitute our value of a, b, c into the partial fractions. So 5x plus 7 over x plus 2, x plus 1, x plus 1 will be equals to a, where a is negative 3. And then plus b, where b is 3. then C is 2. Then this is our final answer. So notice that a proper fraction can be expressed in a smaller fraction, where this smaller form of the fraction we call it as partial fractions.